So thank you very much. It's a pleasure to be here in North Carolina at this important forum, and especially an honor to be on stage with Professor Sunny Ladd, who in my view has done some of the most important work in education over the years. So I'm here to talk to you about the impacts of great teachers, but I'm going to start with a slightly broader perspective and discuss a question that we've been working on in our research group at Harvard over the past several years, which is asking a simple but important question. How can we improve disadvantaged children's chances of success? Or how can we increase, as it's sometimes called, rates of upward income mobility in the United States? Our approach to tackling this question has been to use big data to obtain new insights into these and other policy questions. Many of you are familiar with uses of big data in the private sector. For instance, you hear about Amazon and Google using big data to provide better products. My vision is to similarly use big data to try to improve public policy, and I hope to illustrate that approach here in this talk today. So to begin, I'm going to show you some evidence from an analysis we've done of anonymous earnings records for 12 million children, that is all children born in the United States between 1980 and 1982, and their parents. And specifically, what we look at in this paper that I'm going to describe is we measure kids' chances of moving up in the income distribution relative to their parents. So kind of studying whether the American dream still exists and how it varies across places in the United States. So this chart here shows you what we call the geography of upward income mobility in the United States. We divide the United States into what are essentially metro areas, 740 different parts. And we, in this particular figure, examine a very simple statistic, the fraction of children who reach the top fifth of the income distribution, conditional on having parents who were in the bottom fifth. So it's a simple way of measuring the extent to which kids are climbing up the income ladder. Now we compute this measure separately for each of the metro areas in the US. And as you can see in this map, lighter colors denote areas where kids have a higher chance of moving up in the income distribution. Darker colors are areas where, unfortunately, rates of upward income mobility are much lower. So you can see that there's a lot of variation across the US in the odds that kids move up in the income distribution. And unfortunately, it turns out that one of the areas with the lowest levels of upward income mobility in the US is in the Southeast, and in particular in North Carolina. So that, I think, motivates, for me, why one should be interested in understanding how you can improve rates of upward mobility in the US. And moreover, if you go beyond that map and focus on specific cities, you can really see the dramatic variation across areas in rates of upward mobility, which further reinforces this message. So just to give you some examples, if you were a child growing up, say in San Jose, California, or San Francisco, or Salt Lake City, your odds of moving from the bottom fifth to the top fifth of the income distribution are around 12%. So some people react to that by saying, oh, 12%, that's not really a very high chance of success, right? Well, you have to remember the unfortunate arithmetic fact that you can't have more than 20% of people in the top 20%. So that's why 12% or 13% is actually pretty good, especially in comparison with the cities that are on the other end of the spectrum, where Charlotte, North Carolina, in our data, turns out to be the city with the lowest level of upward mobility among the 50 largest metro areas in the US. And you can see Raleigh, North Carolina, there at 5%. So, substantial variation in the odds, almost a factor of 3, depending upon whether you're growing up in some parts of the US relative to others. So as social scientists and as people interested in policy, it's very natural to ask what is driving that variation in upward mobility across areas and what can we do about it. So in this study that I've been describing, we identify several factors that are highly correlated with these differences in upward mobility across areas, which include the degree of segregation, income inequality, differences in social capital or social cohesiveness, differences in family structure, like the number of single-parent households in an area. And finally, what I'm going to spend time discussing here, differences in school quality. So I'm going to focus on school quality given the topic of this particular event, but also because education is the factor for which I think researchers know the most about causal mechanisms and potential policy solutions. And I'm going to focus in particular, even more narrowly, on one key aspect of education, the quality of teachers. Specifically, the question I want to discuss is how we can measure and improve the quality of teaching with the ultimate goal of trying to improve upward mobility and restore the American dream in many parts of the US. So in the discussion of teachers' impacts, I'm going to draw on work that I've done with John Friedman and Jonah Rokoff, where we again exploit big data to try to learn about teachers' long-term impacts. And so the data we're going to draw on here are school district records from one of the largest cities in the US in the Northeast, where we have data on 2.5 million children who, over the time span that we study, about a 20-year time span, have written 18 million tests. So that gives you a sense of the magnitude of this data. And then, critically, we're able to link these school district records to federal income tax records, which give us information on the children's earnings, college attendance, and teenage births. So with that data structure, we're able to ask questions like, how does the teacher you happen to have in 3rd grade affect your earnings when we see you at age 30, or your probability of attending college, or the likelihood that you have a teenage birth? Now, in order to study teachers' impacts, the first thing we have to do is describe how we're actually going to measure teacher quality in the data. So one prominent measure of teacher quality, which you've heard a lot about, and which was discussed in the introduction to this session, is what are called teacher value-added metrics. So the idea of teacher value-added is really quite simple. It asks how much does a teacher raise his or her students' test scores on average. Now I want to take a minute to describe exactly how value-added is calculated, because many people, I think many teachers, view these value-added metrics as kind of some complicated black box where we don't really have an understanding of what's going on. There are some statistical issues that matter, but really at its essence, the concept of value-added is extremely simple. So teachers' value-added is calculated in 3 steps. First, we calculate each student's test score gain relative to the year before. So suppose, for instance, you're trying to calculate value-added for teachers in 4th grade. You would take the end of 4th grade test scores minus the students' 3rd grade test scores, so that you see how much their test scores are going up over the course of 4th grade. Now, a critical problem with these, potential problem with these value-added measures is that not all teachers get the same types of kids. So some teachers might get kids who are really enthusiastic learners and are making a lot of progress. Other teachers might get kids who are not doing as well in the current year. And so if you just take the straight test score gain, the differences in those test score gains might not reflect the teacher's quality, but could just reflect differences across the students. And so that motivates the second step, which is to adjust each student's test score gain for differences in characteristics. For instance, gender, or whether they're learning English as a second language, and so forth. And we use a technique that's called a regression model to try to essentially level the playing field and account for the fact that different teachers have different types of students. Finally, we define each teacher's value added as simply the average adjusted performance for all the students they taught. So if you taught 4th grade for 4 years, you had 30 students each year, we take the average of those adjusted test score gains over the 120 students you taught. And that's what we call the teacher's value added. Now, are these value added metrics, which are increasingly being used in various ways, are they a good measure of teacher quality? Well, there's considerable debate about this in academic and policy circles, and quite justifiably, I think there are a lot of concerns about using such measures to evaluate teachers or to provide feedback to teachers or for other purposes. I myself, before I started to work on these issues, thought that these value-added measures would be unlikely to really provide accurate measures of teacher quality, but in the course of the research we've done over the past few years, I've come to believe, for reasons I will show you, that I think there is actually some useful informational content in these measures. So the way I'm going to structure my discussion of these value-added measures is by focusing on 3 primary questions or concerns that have been raised about the use of value-added estimates by people who are very prominent in the education literature, like Linda Darling-Hammond at Stanford, Jesse Rothstein at Berkeley, and others. So the first question that is quite appropriately raised is whether these value-added measures are actually accurate proxies for teacher quality. As I was saying, teachers are assigned different types of students, and hence a critical issue is that teachers' estimated value added might depend upon the types of students they get rather than their actual teaching ability. So while we try to adjust for some of the differences in the characteristics across students that we observe, we can't adjust, we don't have data on every aspect of students, right? So some teachers might get very motivated students who are really into learning in that particular year. You're not going to be able to directly adjust for that with the data you have. And so that raises the concern, this is not merely like a statistical issue, it's a very important issue for policy, because if you're not adequately leveling the playing field across teachers, you might end up unfairly penalizing or rewarding teachers for the mix of students they happen to get rather than their actual teaching ability. So are these value-added measures accurate? Well, the ideal way you'd go about answering that question is to run an experiment. The way I like to think about these kinds of questions is, what is the ideal experiment I would run in analogy to a scientific experiment if I wanted to answer this question? So the ideal experiment here would be to randomly assign students to teachers with different levels of value added and study the impacts. Now, you can imagine why it's very difficult to run such an experiment. If I tell a group of parents, I've identified these teachers as being highly effective and these other teachers as being less effective, and I want to understand whether these measures are accurate, let me take your children and run a randomized experiment. Most parents do not want to participate in such a study. So instead, what we're going to do is use a quasi-experimental analog that exploits naturally occurring changes in teaching staff. The idea is to sort of exploit the fact that we have big data, which essentially contains some experiments naturally. And so specifically what I'm going to talk about is the question of whether when high value-added teachers arrive at new schools, does that have an impact on test scores? So let me describe this quasi-experiment as follows. Let's say we're tracking a given school in a given grade, say 4th grade, over time, and we're going to plot average test scores for children who get to 4th grade in that school in different years. So different cohorts of kids who were born in different years, right? So the first set of kids, they get to 4th grade in 1993. The next set of kids get to 4th grade in 1994, and so forth. And what happens in 1996 is that a high value-added teacher enters this particular school and this particular grade and starts teaching in that school. So this teacher is in the top 5% of the value-added distribution. And based on prior data, we've estimated her value added, and she comes in and starts to teach in the school. And what I want to look at is how test scores change around the entry of this high value-added teacher. So there are about 1,000 such events in our data, and I'm going to show you what actual test scores look like when we average over these 1,000 events. So let's start by looking at the evolution of test scores before this high value-added teacher comes in. You can see that test scores are kind of stable around the median, around the 50th percentile. They're bouncing around a little bit. Now, right when this high value-added teacher comes in, test scores immediately jump up, and they continue to remain high for subsequent cohorts of students who continue to be taught by this high value-added teacher. So that is a direct demonstration that when a teacher who's rated as high value-added comes in, test scores do in fact seem to be impacted by the arrival of that teacher. Now, as you all know, in any good scientific experiment, you need to have a treatment group, but if you think back to your middle school or high school science classes, you also always have a control group, which you use to make sure that nothing else is sort of changing at the same time. So a very natural control group in this context is to look at test scores in 3rd grade. Remember, the high value-added teacher is coming in 4th grade. She should have no impact on 3rd grade outcomes because the teaching staff in 3rd grade is not changing at the same time. So let's look at the evolution of 3rd grade test scores. And in fact, you see exactly as you'd predict, there's no change in 3rd grade test scores. It's totally stable around the point that this high value-added teacher is entering 4th grade. So based on evidence like this, it appears quite clear in the data, you can say quite confidently, that these value-added measures do in fact predict impacts on students' test scores. You can also look at this conversely. Where if you have the entry of a teacher with value added in the bottom 5%, unfortunately a teacher with low value added, they end up pulling down test scores relative to test scores in the prior grade right when they enter. So this ends up working across the spectrum. We find that teachers' value added measures provide highly accurate predictions of impacts on student test scores. Now that by itself should not convince you that these value-added measures are good measures of teacher quality, because even though they accurately measure teachers' impacts on test scores, they might not capture the broader impacts of teaching. So do these high value-added teachers improve students' long-term success, for instance, or are they just better at teaching to the test? It could be that high value-added teachers are really good at prepping students for tests, but ultimately what we care about in education is not improving students' performance on standardized tests. We care about longer-term impacts like earnings and things like that. Now, it turns out, using our data, we can look at whether, if you're assigned to a low versus high value-added teacher, whether we see different long-term consequences. And in fact, there are substantial effects 20 years later, 25 years later, from being assigned to a low versus high value-added teacher when you were in 3rd or 4th grade. So this chart here plots the probability of attending college at age 20, college attendance rates, versus your teacher quality in 3rd or 4th or 5th grade in a single year. And what you see is that if you happen to be assigned to a teacher in 3rd grade who was at the top of the distribution, in the top 5%, rather than in the bottom 5%, you're about 2 percentage points more likely to attend college. So that might not seem like a large effect, but you've got to remember that that's the impact of a single teacher in a single year. Now imagine that you have great teachers one year after the other in 3rd grade and 4th grade and 5th grade, et cetera. Then you could end up seeing impacts on college attendance rates of 5%, 10%, 15%, which would dramatically reshape children's lives and reshape the American economy. So the way I interpret this is that teachers have incredibly large impacts on student success considerably down the road when rated even by these simple test score-based value-added metrics. Similarly, you see that being assigned to a high value-added teacher significantly raises your earnings, and it significantly lowers the probability that women have teenage births. Again, a quite substantial effect of about 1.5 percentage points if you're assigned to a high value-added teacher in a single year relative to a low value-added teacher. Now, the third and final critique that I'd like to discuss of these value-added measures is the natural concern, which many teachers have, that they fluctuate substantially across years. So the way to think about why this happens, a teacher's value-added rating tends to bounce around a little bit, is that there are many other influences on student progress. Teachers matter, but lots of other things matter too, like stresses at home or friends or other things like that. And so as a result, test score gains for students fluctuate across years, and because teacher value-added estimates are constructed from these test score gains, they're going to fluctuate as well. An important policy question is whether value-added estimates, which are always only going to be based on relatively few years of data, like 3 or 4 years of observing a teacher, are they going to be sufficiently stable to be useful for teacher evaluation, or are they just going to bounce around too much such that we can't really use them? So there's a lot of debate about this issue that focuses on statistical measures, what are sometimes called reliability measures or correlations across years. My own view is that it's very hard to have intuition about something like a correlation. Is a correlation of 0.5 big or small? That's hard to get a sense of. What is easier, in my opinion, to get a sense of is dollars. What are the monetary impacts of using these measures, given their reliability, for actual evaluation? So to illustrate, let me show you one last schematic, which illustrates the value of improving teacher quality. So I want to emphasize before showing you this that I'm not advocating the particular policy that I'm describing here. I'm just using it to illustrate the potential magnitude of teacher effects. So one way you can think about measuring the magnitude of teacher effects is, suppose we take the teachers who are rated in the bottom 5% of the value-added distribution, and either through teacher training or through some other approach, possibly by hiring new teachers, we replace these teachers in the bottom 5% of the value-added distribution with teachers of average quality. Based on our estimates, we can calculate the impacts of such a policy on the earnings of students. We estimate, based on the results I've shown you, that that change, replacing a bottom 5% teacher with a teacher of average quality for a single year, will increase the lifetime earnings of a child by $80,000, which translates to a gain of $2.2 million for a classroom of average size in our data, a classroom of 28 students. So this is why we think teachers are enormously important for student success. Now let me come back to that question of estimating teacher value added and reliability. Suppose we did the same exercise, but rather than measuring a teacher's true value added, which is what the exercise I was thinking about in the previous slide, suppose we could only estimate it based on a limited amount of data, in particular using 3 years of data. When we only have 3 years of data, we're not going to be able to perfectly identify the teachers in the bottom 5% of that bell curve. Instead, when we try to identify these teachers based on their estimated value added, the teachers whose estimated value added is in the bottom 5%, their true quality has the distribution shown by that red bell curve, where it's more spread out. Not all of them are actually truly in the bottom 5% because there's some fluctuation in these estimates over time. And so as a result, the gains from using value-added estimates based on 3 years of data are smaller. They're $50,000 of earnings per child and $1.4 million per classroom of 28 students, smaller than the $2.2 million if we could perfectly measure teacher value added without any error. But I would argue $1.4 million is still a substantial change and still should be something we're interested in, right? And so there's still, from this perspective, substantial content in these value-added measures. So let me conclude by talking about the lessons that I draw for education policy from this work. The first and most important lesson, stepping back from the details of value added, where people get, there's a debate about that particular measure, but in my view, that's sort of missing the forest for the trees. The big point here is that teachers are really important, and it's important to attract top talent to teaching. Whether you use value-added measures or you use some other approach, trying to structure the teaching profession in the US, maybe like in Finland, as we heard about, will have incredible value for students and for society. Second, I haven't had time to describe these results, but we find that teacher quality matters in all grades, not just at early ages, as some have suggested. We find evidence that teacher quality may be more important than class size. And lastly, we find, as I've been discussing, that test score-based value-added metrics can be helpful in identifying good teachers. My view is that they may be most useful when combined with other measures of teacher effectiveness, like classroom observation and principal ratings. But it's hard for me to believe, given the informational content that they have, that the best policy is to completely ignore these measures. At the least, you might want to let teachers know about their own value added. So to conclude, let me come back to what I started out with, which is about differences in upward mobility across areas in the US. You can look at the chart that I've put up here, which returns to these statistics, either in a negative way and be disappointed that places like Raleigh, North Carolina, or Memphis, Tennessee have relatively low odds of success for disadvantaged children, or the way I'd like to look at it is that this presents an opportunity and a challenge. The opportunity is that we see that there are many places within the US, such as Dubuque, Iowa, or San Jose, where children from low-income families have substantial chances of succeeding. And that illustrates that we can, in fact, make a significant difference in kids' lives. It's not just a preordained thing that there's no way to make a difference in rates of upward mobility. The challenge for us as researchers is to determine what the differences in policy are across these areas that are generating these differences in upward mobility. And the challenge for the policymakers and others who are here today is to try to implement those solutions so that we can have equal opportunity from all, from North Carolina to California. Thank you.